Hello everyone, hope you are doing well. I am Parmar, Assistant Professor at LJ Institute of Engineering and Technology in the IT department. Today we will learn an interesting data structure topic, TCP-IP model, right? Which is the base of the networking. Generally, TCP-IP model is learned after better understanding of the OSI model that we have already did. So what is TCP/IP, how it works, what are its layer functionality, and many more interesting things we will cover in this today's lecture. Please refer whole lecture thoroughly to better understanding of the computer network and data communication, right? If you understand this concept very well, after that you will hardly have any problem or trouble with the understanding of the computer networks or data communication. Let's see the outline of today's lecture. First of all, we will see the prerequisite as a OSI model overview that we have already learned. After that, we will see the use of the TCP/IP. After that, we will see an interesting myth about history about the connection of the OSI model and the TCP/IP. Right? After that, there are the various confusion about the layer structure of the TCP/IP that we will clear in this section. After that, we will see the formation of the TCP/IP model. After that, the protocol that makes the TCP/IP defined that we will see, right? After that, the features of the TCP/IP and the networking issue we will cover. After that, we will see all the layers in brief, right? Let's start with the prerequisite of the OSI model. If you haven't referred the OSI reference model thoroughly, so for the better understanding, please visit that video, watch that video and learn thoroughly, right? There are one general question, why there is a need of the modeling. If we do not follow any modeling system, all the tasks like application, the wiring, the sending of the data, encryption, addressing, all the tasks have to perform in the single layer. If we divide that task into the layer by layer, that is easy to maintain and easy to manage, right? That's why we need a model. In this type of modeling, the task is divided into the network model that is broken into the manageable chunks, right? In the OSI model, there are 7 type of layers are present. In the particular type of layer, there are several tasks is divided among that, like an application layer, presentation layer, session layer, transport layer, network layer, data link layer, and at last the physical layer. The first 3 layer is a software oriented layer, and the last 3 layer are the hardware oriented layer. In the middle, the transport layer, which work as a bridge between that software kind of layer and the hardware oriented layer, right? Let's have a quick recap about the OSI reference model. What are the tasks of each layer? The application layer that allows the access to the network resources, which provides the GUI to the user. The presentation layer, which is linked with the encryption and the decryption model. After that, the session layer is used to establish a session between the source and the destination. After that, the transport layer, which provides the process to process message delivery and error recovery task, right? After that, the network layer is present, which is used for the moving the packet from source to destination and provide the inter-networking, right? And the second last layer is the data link layer, which is used to organize into the frames and provide the hope-to-hope delivery. And at last, the physical layer, which is used to transmit the data into the bit format into the transmission media, and this is how the data is transformed from source to destination, right? After that, the protocols which are linked with each and every layers are listed here. After that, we will see the transformation of the data from data to the bits, right? In the application layer, presentation layer, and the session layer, the data present in the data format. After that, the data is transferred into the segments in the transported layer. After that, segments are delivered to the network layer. That segments are divided into the packets, right? And that packets are sent to the data link layer. In the data link layer, that are also divided into the frames, right? After that, in the physical layer, that frames are converted into the bits, and that bits are traversed through the physical medium. We can say that the transmission media from source to destination, right? Or in the similar way, the data is converted from the bits to the frame and packets and segments, and after that the data is converted into the data, right? This is the quick recap about the OSI reference model. Let's see the what is TCP/IP model and how it's work, right? We learn an OSI model in brief, right? Generally, the TCP/IP model is learned after the OSI model for the better understanding, right? The TCP/IP is a combination of the TCP and the IP protocol. With the help of that protocol, you can communicate without any dependency. With the help of the TCP/IP model, you can communicate without any hardware dependency. If you want to communicate between the two devices which is manufactured by the two different companies, it is really easy task after the designing and after the evolution of the TCP/IP model, right? The basic question arises, where does the TCP/IP protocol is used, right? The TCP/IP protocol is work as a transport layer which is used for the acknowledgement of the data and the sequencing of that data, right? And the IP protocol is the work at the network layer protocol which is used for the addressing and the deciding the path of the data traversing, right? So this is the basic task of the TCP protocol and the IP protocol. We will start the understanding of the TCP/IP model with the comparison of the OSI model. But before that, we will see one interesting myth which is very famous about the TCP/IP model and the OSI model's relationship. Let's see one interesting myth which is very famous about the relation between the TCP/IP model and the OSI model. The myth is the TCP/IP protocol is evolved from the OSI reference model, right? You are from the any college, any region, in any country, or you are from the US, you are from the Canada, or you are from the India. We have told that the OSI model is a reference model and TCP/IP model is evolved from the OSI model. But I want to tell you that there is no connection between the TCP/IP model and the OSI model in the designing phase. Both are designs are independently. There are no connection in the designing process or this kind of relationship, right? When both the models are in the designing phase, no one is aware about there is a similar kind of innovation or similar kind of research is going on, right? Both the models are developed by the two different bodies, right? If someone asks you that how many layers are in the TCP/IP model, some of you will answer that there is a 5 layer in the TCP/IP model. You might be right. And some of you will answer that there are a 4 layer in the TCP/IP model, that they are also right. In the book Forozen, which is widely used as a reference book in the different countries, in the different colleges, they are following the Forozen, which is having a 5 layers in the TCP/IP model, right? The Tenenbaum, which is also a good reference book, which is also referred in the so many colleges and the university. That Tenenbaum is following the 4 layers in the TCP/IP model, right? If you are asked that how many layers in the TCP/IP model, so you can answer that 5 or 4. Both the answers are right. So there is a one confusion there, right? Why there are a 5 layers or the 4 layers, right? You might be amused at why the OSI model have the 7 layer universally, but the TCP/IP model have 5 or 4 layers, right? So for that answer, the TCP/IP model is not evolved from the OSI model. When both the models are in the designing phase, none of them are knowing about each other's research, right? The ISO standard has designed an OSI reference model when the DARPA scientists, which was working for the American Defense Ministry, have developed the TCP/IP model. When the ISO was designing the OSI reference model, the scientists have done the really good paperwork. Before the development of the OSI and the TCP/IP model, the hardware was dependent on each other, right? In that, the Dell laptop can only communicate with the Dell laptop, HP laptop will only communicate with the HP laptop, and Apple system will only communicate with the Apple system, like that. So the hardware dependency there. So to overcome that problem, they designed the model which is really hardware independent. By this, you can communicate from the Dell laptop to the HP laptop or the Apple laptop, and vice versa, right? So in this way, the hardware dependency was gone, right? The ISO has focused on the paperwork only. They thought that we will implement after that, and the DARPA scientists, they have the focus on the real implementation. They think that the first implement and after that we will do the paperwork, right? So this is how the OSI model is well defined, the reference model, and the TCP/IP model was a practical implementation of the model. And American defense wants a network in that the Russia cannot intercept, right? So this is how the TCP/IP model was designed. When we are forming a layer, the name and the working of that layer might be similar, but there is a no relationship in the designing phase, right? OSI model is not really implemented, but yeah, the OSI model is a best model for better understanding of the computer networks, how to communicate and all that. For that, the OSI is the best model for that. But when it is come for the practical implementation, then TCP/IP is there. The TCP/IP has a wide range of real life usage, right? So the OSI model is only a reference model, right? By that, it is best model to implement the network. The TCP/IP is a practical approach and being used widely, right? Let's see the layering formation of the TCP/IP protocol. But before that, let's recap about the how the layer of the OSI model. I have given one short trick. All the people seems to need data processing. We will take one initial from that word, A from all, P for people, S for seems, T for two, N for need, D for data, and P for processing. We will convert them into the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer, right? This is how the layering of the OSI model is formed. But when someone will tell you that what is the layer formation of the TCP/IP, the first three layer, application layer, presentation layer, and the session layer is merged together and form and one application layer for the TCP/IP model. The transportation layer and the network layer is remain same there, right? But if you follow a file layering as mentioned in the Forozen book, the data link layer and the physical link layer is there. But if you are following the Tenenbaum, which is having the 4-layer structure for the TCP/IP model, then the data link layer and the physical layer will merge, right? So this is how the TCP/IP model have the layer functionality, right? Let's see the first of all the 5-layer type of functionality which is mentioned in the book of Forozen. The first three, the presentation layer, application layer, and the session layer are merged together and form in one application layer, right? After that, the transport layer will remain the transport layer. The network layer will convert into the internet layer, which have the similar kind of functionality, right? After that, the data link layer and the physical layer will remain same. This model is mentioned in the book Forozen, right? After that, you will follow the Tenenbaum, then data link layer and the physical layer will merge and will form a network access layer. So the both the model, which if you are following the 4-layer architecture or if you are following the 5-layer architecture, both the layer are same, right? So you have one question arise that okay, why there are a 5 or 4-layer kind of system in that for the TCP/IP model? So the answer of this question is when the TCP/IP model was designing, they implemented first and after that, and that's us who are trying to do some paperwork about how the layer, how the TCP/IP model is working, how the layer is formed, right? So this is how the layer formation of the TCP/IP is evolved, and we can see that we have done the paperwork, right? If we follow the 5-layer kind of TCP/IP model, there are layering, the physical layer, data link layer, network layer, transport layer, and the application layer. The first 4 layers provide the physical standard, network interface, the internetworking, and the transport functionality. As we have already discussed, the top 3 layers of the OSI model represented in the TCP/IP model by the one single layer which is called the application layer. This is same in the both kind of modeling. If you are following the 5-layer kind of modeling or if you are following the 4-layer kind of modeling, right? But if you are following the 4-layer kind of modeling, the last 2 layers, the data link layer and physical layer will be merged and taken as a single layer which is the network access layer. Let's start the working of the each and every layer. Let's start with the application layer, the layer which will introduce first to the user, right? The application layer will connect it directly through the application. If you are using a Gmail, if you are using a Facebook, if you are using a WhatsApp, if you are using an Instagram, or you can say that if you are using any kind of graphical user interface, they are connected by the application layer. The protocols which are followed in the application layer is DNS, DHCP, HTTP, FTTP, TFTP, SMTP, SNMP, and all that. That protocols are used for the surfing on the internet, like domain name services, hypertext transfer protocol, file transfer protocol. That all the protocols are used for the surfing on the internet, right? The user will get the interface by this application layer, right? So this is how this is the fundamental work of the application layer. So the fundamental task of the application layer is to provide a user a graphical user interface, right? Let's move forward about the another layer, the transport layer. The transport layer is also called a host to host layer, right? The most important term, the TCP-IP, the formation of the model name, the TCP, is come from the transport layer. The transport layer has majorly two kind of protocol, the TCP and UDP. Let's see the TCP first. The TCP is a connection oriented protocol. With the help of the TCP, you are getting the acknowledgement if the message is delivered from sender to receiver. If the data is not delivered properly, then the retransmission is also possible by the use of the TCP. The TCP protocol will ensure about the sequencing of the data and the originality of the data. The TCP protocol is used for the non-real-time data. If you want to send a real-time data such as PDF, document, Word file, PowerPoint presentation, image or video, then you can use a TCP protocol. It is really slow compared to UDP, right? It is reliable. It gives information about each and every sequence of the data, how the data is sequencing, and all that task is performed by the TCP protocol. If you want that, if our data is delivered successfully or not, then you have to use the TCP/IP model. Just like that, the double tick functionality in the WhatsApp, message delivered in the simple SMS system, your email is successfully sent, or you can say that the sent in the email system, that all the task is performed by the TCP protocol in the transport layer. If you don't want any acknowledgement about your data is sent from source to destination, then you can use the UDP. If there is a no need of the retransmission, if the packet is failed to deliver, then you can use the UDP protocol there, right? This UDP protocol is widely used in the video calling, in the voice calling, as you are enjoying the OTT platform like Netflix, YouTube and all that. That at that time you don't need a retransmission of the data if they are failed to deliver, right? When you are experiencing the real-time communication, then you can use the UDP protocol there, right? This is a basic difference where the TCP/IP is used and where the UDP is used, right? The TCP and the UDP is the most important topic in the data communication and computer network. With the term TCP protocol, the whole model has taken its name, the TCP. After that, the IP, the Internet Protocol, is used in the network layer. Is an also a most important topic. Like you can say that the Internet layer or the network layer. In this layer, the sender and receiver's IP address assignment is taken a place. In this layer, the routing is forming. By this, you can find out which path to follow, who are the authenticate user. In this layer, the routing is formed, right? Which path has to be followed by the data from traversing from the source to destination. It is decided by this layer only, right? The authentication of the user, right? It is authenticate sender or it is authenticate destination. It is also and decided by this layer, right? Right. The main task of the internet layer is the forming the connection between the two devices by the assigning the IP addresses, right? If the one is sending the data, the track about the reaching, right? So this is the major task about the internet layer, or we can say that the network layer, right? This is the most important protocol in the TCP/IP protocol, right? We have taken TCP from the previous layer and the IP from this layer, and with the combination of this TCP and IP protocol, we have formed this model. So the name TCP/IP model is dragged from the TCP protocol from the previous layer and the Internet protocol from this layer, right? So this is how the TCP/IP model is formed. After that, the data link layer and the physical layer is there. If you combine the data link layer and the physical layer combinedly, it will form a network access layer. You can say that the host to network layer. The combination of the data link layer and the physical layer is called the network access layer, or you can say that the host to network layer. The MAC framing is forming in this layer. The major protocol which are used in the network access IP, address resolution protocol. Yeah, we can say that ARP, RARP, ICMP, IGMP, and all the protocols are used in this layer. We will see the functionality and work of each and every layer in our upcoming videos, right? Let's have a brief review about which kind of protocols are used in which kind of layer. Here the application layer, presentation layer and session layer are merged in the application layer. The major protocol which are used in the application layer are SMTP, FTP, DNS, HTTP and many more. In the transport layer, UDP and the TCP is the major protocol which are followed. SCTP is also a protocol which is used with the transport layer. In the network layer, IP protocol is the major protocol which is followed in the network layer, right? After that, the other protocols which are used in the network layer is ICMP, IGMP, RARP and ARRP, right? After that, in the data link layer and the physical layer, it is also called an host to host network, right? If you combine the data link layer and the physical layer both, right, it will form an host to host network. So this is a scenario how you are sending the data when you are want to send a big file, how it is delivered to the destination. This is the one real life example. This is how the data. This is how a one big file is sent to the destination in the order, right? When you are want to send a data file which is large enough, it is divided into the manageable chunk. After that, it is when you want to send a big large file, it is divided into the manageable chunk. After that, the addressing and the sequencing number is assigned. After that, that is delivered into the physical path, or you can say that in the physical layer. Or after that, the sequential after that, the sequence of the data is delivered into the after that, the sequence datagram is delivered by the communication system to the destination. Destination will get the sequence of the destination will get that divided manageable chunks which have the address and the sequencing number, right? With the sequencing number, the data is combined and sent it as a big file with and send it as a large file which is sent by the sender. This is how the destination will get the information which is sent by the source. This is how the destination will get the information, the actual big file, the way in the form of the source has sent it, right? Right. After that, you have one question arise, how many type of addressing is there? There are majorly four type of addressing. In the physical layer, the physical addressing is there. In the network layer, the logical addressing is there. In the transport layer, the port address is there. And the application layer, if the specific addressing is required, then they are also given an address to that, right? Let's see each of the addressing in brief. In the physical addressing, is usually known as the MAC address and it is fixed for the system. You cannot change the MAC address for devices, right? The logical address, it is used to identify a host in the network. For an example, you are assigning an IP address which can vary from the destination to destination. After that, the port address, the IP and the physical address for a quantity of the data to travel from source to destination, right? But when the arrival of the data at the destination is not the final objective, you can assign and port address in there, right? When the multiple processes are running simultaneously, then you need a port addressing. So the label of the port address is assigned to each and every process. So the process will get the requested data by the port address, right? The specific address, email address, URL are the special kind of addresses which are work with the application layer. So this is how the addressing the TCP/IP model is used. So in this lecture we have cleared about the use of the TCP/IP, how they are formed, how they are designed. We have clear one myth about the TCP/IP and OSI model doesn't have any relationship in the designing phase, right? And the functionality of each and every layer we have seen here, right? After that we have seen the protocols which are used in each and every layer in brief, right? After that we have seen the addressing which are used in the TCP model. Thank you for the watching.